Hi, my name is Aaron. Today, I'm going to take you through a code review of a SwiftUI application that was originally written for MongoDB Atlas Device Sync Realm SDK and converted to Couchbase Lite or Couchbase Mobile to work with Couchbase Capella App Services. Now, this code can be found over on GitHub. There's a video link to that code in the video description here. So if you scroll through the description, you'll find a link to the actual repo of this code. Now, in the repo itself, there is a README. The README file is going to give you a lot of great information. So one, it's giving you a link to the original MongoDB application. It's right here. And that repo is over here, which you can go through then and use to do a kind of diff between the MongoDB version of the application and the Couchbase Lite version of this application. I'm going to start out with the elephant in the room of this, since this is a code review, to start out with the very first paragraph that I have in the README. The original app is a basic to-do list, right? And I have it here, and there's previous videos where I demo out this app that you can go take a look at it and see how it works. I have it running, as you can see here in the simulator right now. But the Realm SDK has a very specific SDK. There's two of them. There's one for Swift and one for SwiftUI. The one for SwiftUI is a very specific SDK. It integrates very deeply with SwiftUI. Couchbase Lite does not have that. There is nothing available today for Couchbase Lite for SwiftUI to have that level of integration. We have a Swift SDK. It's a good SDK. However, it's not going to be integrated into SwiftUI like that. So because of that, while this is a conversion, there's very little bit of the application outside of the UI is going to be the same from a data layer access standpoint, right? Because of the fact that SwiftUI, the integration that it has, is so deep in the code, we just don't have anything like that. And to try to build that, you're literally trying to build the Mongo Swift SDK then, the Swift Lite SDK, the SwiftUI SDK. And that's just something that you could try to do that, sure, if you wanted to, but that's going to take a lot longer than just converting the app over. So because of this, a hard decision had to be made. And if you're watching this video, you're going to have to make that same decision, right? I have been doing mobile development for quite a long time. And what has emerged as a pattern here in the mobile world of whether you're talking Android, you're talking Swift, or you're talking .NET, where this pattern originally came from, is the MVVM pattern, okay? And Paul Hudson, he's a very famous person out there in the Swift world. He has a great video that introduces you to the MVVM pattern. This stands for Model View Model, if you've never heard of it before. I'm pretty sure if you're a Swift UI developer, you have heard about this, whether people talk about it or not. And the nice thing is it kind of fits nice into the observable pattern. Most people don't know this, but it actually was originally designed by Microsoft for the .NET framework, and for UWP, it stands for Windows Presentation Framework, okay? And it was designed with observables in mind. That's a pattern that also came from, and there's something called the iNotify change. This is a .NET video, but what I'm trying to explain to you is that this pattern has been around for quite a while, and it's very stable. So in my opinion, based on looking at some of the biggest YouTubers out there, the biggest people in social media talking about how to build really great applications in SwiftUI, my recommendation and what I did was I converted this over to an application that uses a 3-tier approach. It uses a service called a database service. It uses a view model to handle the binding between the database service, which is going to handle all the interactions with the database. So we're going to have that view model talk to that database service, and then the view model is going to hold state for the UI and then send information down to the UI as needed. So it's a 3-tier kind of design. Like I said, database service as the root of it. Then you go in, you have your view models and then your views. And I have an app overview diagram that kind of explains this. You can see where the app flows. So you can see here, there's a core basic app. I had to make a CBL app. I'll get into that when we go through the code. You can see here that the whole app starts with a content view that's normal in a SwiftUI app. And then we need to kind of calculate where it should go based on the current user logged in. And this is the original flow of the application hasn't changed. I did not change any of it because this is a conversion, right? The goal is to keep the UI and the flow of the application the same, only change out the data access layer. So it checks if the current user is not logged in. If not, it goes into a login view. The login view added to it is a view model, and it talks to 2 different services. And I'll get into why that is in a few minutes here. But then if the current user is logged in, we open a database view, and this open database view is from the original application. It has a view model. It then tries to figure out the database state to figure out what should show. Should the error view show? Should a progress view show? Or should the list of items, the tasks in the list show? And based on that, you can, in the items view, you also can interact with this little button here, this plus sign that says, should you create a new item? Now, on top of that, because this is a SwiftUI application using components, it has a component called list items, and this was from the original code. And then the list items are just a row. There's a set of rows, right? And so that component's broken down to a row. And then a row, when you click on it, you can go into an item detail. Okay, and that gives you the ability to edit an item then, right? When we kind of go through here, and that's the item detail here. So we have a kind of overview here of that this item's view right here is this one right here, and that is the listing that shows from the application. If I were to log out, I can even show you that this is the login view right here, right? And when I click login, it's checking this state to see whether an open view should show. And when that happens, it's given the list view almost instantly because there's, it pulls the data that fast from the database. So that's an overview of the overflow of the application. Let's take a look at the actual physical code that was required to change from a high level inside of Xcode itself. So I'm going to bring Xcode open. I don't have the app currently debugging right now. I was just running it from the simulator, right? So the very first thing, as I kind of told before in the previous videos, is that we have this Capella config. So the very first thing I did was I deleted the Atlas config and I made a new one called Capella config, and it keeps the URL endpoint to the actual Capella App Services that you're going to use inside the app. That's the very first thing, no matter what, that kind of went through it and got changed out. The second thing is the package dependency. Okay, obviously, if you're a Realm app, you're going to have a package dependency on Realm. I removed the package dependency for Realm and I added one for Couchbase Lite. As you can see here, this is the Couchbase Lite Swift dependency. And you can use the UI for that. You can go to packages, you can go to resolve packages, add packages. You can add packages over here. However you like to build, add your package dependencies, you can do that over here in Xcode. And then you just basically can search for one, you can add one, just like the normal packages that you do in Xcode. So I went through, added the Couchbase Lite, and then removed the Realm. The next thing I had to do is I drew that application flow because I knew that I was going to have to fix the application. But in order to do that, I didn't write this app. I needed to know how the application worked. So I actually made that diagram pretty early on so I could understand before I wrote a drop of code, where was I going to need to inject certain things into this in order to make everything work. Once I did that, I had to go through and learn the Realm SDK, which, that's out of context of this video, but what I figured out is that the app, basically when it starts, there's an app, right? And the app's gonna go through and make this app object. Well, the original version of the Realm code made just a Realm app. And so I knew that I had to emulate the things that the Realm app did inside of my code. So if we go back and take a look at the original Realm code here, you'll see here in the app itself, I'm going to just go ahead and use GitHub to show the original code here. You'll see here that very early on it makes a new app, and this app is actually of type a Realm app. And that's, you can see right here, the Realm SwiftUI app. Okay, so I knew that I was going to have to go through and create something very similar to that so that I would have the same kind of flow inside of my version of the app. And that would also minimize the amount of code I'd have to refactor. So this Couchbase Lite of the CBL app basically keeps track of the current user because that's what the original one did. It's going to keep track of the app configuration. It's going to pull that from that file there that I talked about earlier. It's going to keep track of whether or not there's an error state and then the current database state. And this is all based on what the Realm version did, right? And so these are observables, and I published those because that's how the original app was designed, was to interact with this to figure out what it should show on the screen is based on this database state, okay, right here that we publish. And of course, there's some code here just to show errors, if there are errors, and set the current user in a database state. I went through and made the exception messages. I went through, looked through all the Realm exceptions that could be thrown, and I made sure I emulated each one of those exceptions so I could throw the same exceptions. So basically the idea was, because they're the same name, I don't have to change that code out. I know that they're gonna work the same way. So that was the next thing I did, was went through, understood which exceptions Realm was throwing, and made sure I kind of went through it and duplicated those. So inside the app, we go through and we make one of these, we load the config. This code works exactly the same. So there is a load app config function, right? And if I go through and go to that definition, you'll see that this is inside of the app config class. And when we load the config, this is almost the same exact code that they had. The only difference literally is I pull from a different file name, and then I have different resource names, right? So I have an endpoint and a Capella URL. Outside of that, exact same code that came in from the original Realm app, just had to update it to use my version and my name, so the config files and the fields inside of the file to get those properties back. So outside of that, nothing else. I renamed the app because it obviously said Realm, and this is, I work for Couchbase, so that's, that's something that we're, don't need the marketing there. So I just renamed it. There's no value to renaming it outside of just making it so it's very clear that this is not the Realm version anymore. The error handler passes in the app. So I had to go through and change that from being a regular app, the Realm app, to being a CBL app. And then basically the errors and everything else should just work fine through that. Here's where everything gets a little different. So, like I said, we don't have the SwiftUI framework that Realm does. So because of that, I then, in the app itself, new up a new database service. And then I'm going to use environment objects to pass in both the view models down to to any view that needs them, right? And then the view models will have the service. So they'll never have a direct talk. No views can have a direct talk to the database. They're always going to go through a view model. So for each one of the views I had to keep track of, I made a view model for those. I pass in the service, and this is my version of dependency injection. There are frameworks out there that do dependency injection, probably better than this, but this is the built-in way that Apple provides. And I wanted to try to provide the best built-in experience using just the standard SDK out of the box, because that's probably what most people are going to do. If I start bringing third-party or open source projects in for doing DI, I'm getting a little bit more opinionated that I probably want to be in this conversion. Also, every package you bring in is going to be possible regression or possible things that you have to manage long-term. So I wanted to keep the packages down to just the Couchbase Lite package if I could, and just use the built-in stuff that Apple provided. So that's the reason why I made the decision to use environment objects and use the concept of the main app loading the service early on, making a new one of them, and then sending it down to the view models itself. All right, to a pointer, right? So if we take a look then, really we want to go through and talk about the view models, and then we'll talk about database service and how this all works. Now, the very first part of the application, we go through and it authenticates the user, right? So we could start there by saying Realm out of the box handles its own authentication. It had its own library for that. And it's pretty early on. You can see if you go into the views, there's a login view. In the login view, you can see here there's a username and password that it keeps track of in state. We go through and we check if it's logged in. If it's logging in, which is a state, then it's going to show the progress view. Otherwise, it's going to show this view. You'll see here that there's just an await function here on a task, so it is using Swift concurrency. And I made sure that everything I did inside of my code would use the latest version of Swift with concurrency, because that's how this was written. And so we can go find that login function to see here that it's going to do the app. And so this is the app, the Realm app, right, has authentication built into it. Couchbase Lite does not have authentication built into it in its SDK. Okay, the replicator will handle authentication if you give a username and password, but you have to look at an event that gets thrown a listener to see whether or not the username and password work. It's not the same pattern, right? So I had to now make another decision, like how do I solve that? Well, I like separating code, so I'm gonna go back to Xcode real quick here instead of GitHub. And I decided to make the decision that rather than having the app do it, I'm going to make a protocol and a class to do this called the authentication service. Okay, I made it a singleton because that seems to be a popular thing here. I could have made a protocol for it and injected it, an implementation, and then had a mock version of it to keep the code. There's so many differences in this code. I didn't want to confuse developers too much. Try to keep it as simple as possible. So you'll see here, because it's a singleton, you're going to have a static shared. And that's how you get back to it. Here's our login function. How this code works is that it's going to use the App Services REST API to go through and authenticate the user. If the user authenticates in, that's great. It's going to return a new model object of a user. And that's the next thing I had to build, because Realm has a user object and Couchbase Lite doesn't out of the box. I just made a struct called user, and I keep the username and password in memory from that, based on that, to emulate the Realm SDK's user object that they have, that they pass around, right? So within that, a couple things. One, if you remember from the config earlier, out of the box, App Services uses WebSockets to talk. So that's what WSSS stands for. That's Web Secure Sockets. So it's like an encrypted version of WebSockets versus non-encrypted. Well, when I'm using the REST endpoint, I need to convert that over to HTTPS because I just want to use standard WebSocket, or not WebSockets, standard, REST API calls, right? Now, the other thing is when I'm checking reachability, I don't want to check the endpoint URL. I just want to check the main site to see whether or not it's working with DNS. Make sure that you typed in a name into the Capella config file that actually works. So I have this reachable method. All the reachable does is make sure that this is actually available. And if it's cool and you can reach it, then I send back, it's a true or false, a Boolean, right? And so that will tell me whether or not to throw the error that this URL is not good, it's not reachable. Then I go through and I encode the username and password, standard REST API stuff, right? So I encode the username and password into a base 64 and using Unicode 8-bit. And then I make a request, call the GET API for that particular REST endpoint and see whether or not it works. If I get a 200, I return back a new user. If I get a 401, I throw the invalid credentials, trying to use the same exceptions as much as possible that Realm had. And if I get some kind of other thing that's going on here, then I throw a generic NS error in order to get that to show up in the UI. So that's my version of an authentication service. Now, with that, should you use this? Well, this is going to get into a little bit more complicated of a conversation, but for a simple application, that's great. You can use it that way, but inside of Capella, I highly recommend, and in the README file, I go through and try to explain this, that really, when you do this, under the authentication section here, you should probably take a look at OpenID Connect instead. So I'm gonna just kind of click on this link here, and this will go right to the Couchbase docs to explain it. Here's the reason why. OpenID Connect, there's all kinds of providers out there. You have your Auth Zeros, you have your Ping Federate, you have your Microsoft Entra, Google has it, right? I mean, I can rattle off all kinds of different authentication providers. Most of the authentication providers that are doing this at scale give you an authenticator app that you can kind of go through and do multi-factor authentication, all those kind of things. They do security the best, right? So I don't recommend rolling your own security. Have somebody else that can do it better, do it for you. The advantage is they're going to have the password out of memory. And that's what I wanted to talk about real quick. Remember that in my code, if we go look back at Xcode, I'm going to have to keep that password in memory to send over to the replicator. Well, in the world of security, especially if you're building financial apps and stuff, you want that password out of memory as fast as possible. And if you can help it, just not to have it in memory at all in your application. And that's why there's a lot of times people use like web-based technology to try to do authentication. They try to keep it so they can throw it out of memory from the web browser cache as fast as possible versus storing it in memory in a native application. So my recommendation, once again, this code works. It works without problems. You've seen the demo of the app if you watched the second video in the series. And you can use REST API if you want, but if you want security, you really want to go through and take a look at that documentation that I have linked out here under the authentication section of the README file that goes through and explains how to go through OpenID Connect and use that instead. It's a much better way of authenticating, but I needed to make this app simple, right? I mean, we're trying to go through and explain the conversion process. If I have to then explain you have to go get your own OpenID connected stuff, it just adds, like I said, the amount of technical debt into having just a conversation about how to convert an app that it's too much. So instead, like I said, I use the REST API. However, I do recommend that you don't, if you can, and use OpenID Connect instead. Okay, or roll your own security modules if you need to. But then once again, you're getting yourself into a lot more things that need to be done. So what ends up happening then is that we have a login view model. Okay, and the login view model is going to go through and do the logging in. It's going to then go through and use the authentication service because that's a singleton. It can go through, find a user. If it's great, if it has a login user, we're going to make that login user. We're going to go through and tell the because the user's logged in, we're going to initialize the database service and then tell it to take that user to initialize that database with, and then we can set the state of the app to the current user, and that's what's going to tell the app then to change, because there's a listener that listens for this. It's an observable inside of the app, right? And I showed that earlier. Once that happens, then it's going to go through and say, oh, okay, this has changed, so now I need to go through and change and update the UI based on that. But we want to make sure we initialize the database first before doing that. So with that, let's take a look. So now we understand the flow of the authentication, and we can see even in the login view that basically we get the view model from the environment object. And now the only difference is that the await login function here just calls the view model login. So that's the change, right? Before it was kind of calling the app to do that. I want a separation of concern saying, look, I'm gonna handle all the stuff I can inside the view model instead. It's a better way to do it. In fact, even the state of the username and password is handled by the view model. And that's the pattern, right? You're gonna move state out of the view into the view model, and that's gonna be your glue between your view and your whatever services that you're writing, etc., right? And that's gonna give you more testability, because now that the view is just completely blank, it's really easy to test the view and you can test those view models separately, better testability. Like I said, Paul Hudson, so if you've never done MVVM before in Swift, I highly recommend Paul Hudson's video on this over in Hack with Swift. I'll leave the link in the description and go through, watch that. It's brilliant, and it really is a better way to build Swift applications if you care about testability. So with that, let's take a look at the database then service and take a look at the init function. So in the database here, first, I need to emulate the state, and this database state is very similar to the realm state. Now it's a little bit different because we have a replicator, right? And so I've put some comments in about, like, for each one of these, this is what's happening in that state, so that I could try to keep the names as close as possible, but also explain what really happens during those states. We can see here that this is going to use Swift concurrency, and Swift concurrency means that the database service is going to use an actor, right? And this is just saying what kind of threads I should run. I assume that if you're a Swift developer, you understand Swift concurrency, you understand what actors are. I'm going to put a magic string in for the name of the scope and collection so that I don't have to manually type those strings in and instantly type them wrong because they're just strings. I keep a pointer for the replicator and the replicator status so we can see what's going on if the replicator fails for some reason. Obviously, we're going to keep a pointer to the database and the collection. The collection in Couchbase Lite is what stores documents, okay? And so think of a scope as like a namespace, and then think of a collection like a storage of documents. And you can have multiple collections if you want in your application. And for each type of document, you can then have a different collection for those. I have two queries, and I'm going to cache those queries. In Couchbase Lite specifically, okay, we have a query language called SQL++, which you can learn, and it's very pretty much looks exactly like SQL. It just adds ability to have nested documents or arrays. And so those two features are added on to the SQL language, and that's why we call it SQL++. You may also hear it called NQL or N1QL, and they mean the same thing, SQL++ or NQL. How it works is that when we take a SQL++ query, we actually compile that down into something called the Fleece engine. The Fleece engine is what actually kind of talks between the SDK and the database storage. And so every query that you create in the memory is going to be compiled down into something that Fleece can then use to talk to the database storage. Well, every single time you switch in this application, let me go show you that. It's on another screen here. Every time I switch a switch, what it's really doing is swapping out a query. Well, I don't want to make a new query every single time because really there's only two queries in this. There's show me all tasks, right? Regardless of the user logged in. So give me everybody's tasks. And then obviously I want to see mine, but everybody else's, or just show me my tasks. Since there's only two ever queries here, if I were to make a new one of these every single time, this is a lot of waste. Okay, it's not efficient, chewing up memory, and then the application is just, from a profile standpoint, that doesn't make sense. So I know there's only two queries in the application. I'm going to cache those so that when I create them, it'll create them compiled down, and this is going to make the application more efficient. Now, of course, I need a change listener. I'm going to get into live query a little bit, but the change listener is used for live query, and you can see that right here. We have an observable, and then we also have the live query. And I'll get into what those means in a little bit. When you init the database service, it's just going to set some logging up so you can see the debug. But really, most of this is going to come down to this pretty long initialized database function. The first thing we need to do is tell the app that we're not initialized the database yet, to set the state of that, okay? And that's because, once again, like I said, the app keeps track of what's going to draw on the screen based on this state. I go through and I pull the user that's currently logged in into the application, and I need that because I'm going to use that for the database name, okay? Each user that logs into the application is going to have a separate database name. By doing that, if you have a tablet, like an iPad that's shared between multiple users logging in, each user will have its own separated data. And this is the recommended approach when you have a device that's shared between multiple users, like an iPad, for example, is that each user should probably have their own data. That way it's guaranteed that their data is secured to that user. And that's a good security model to follow. Now you'll see here, I go through and try to make a database, and then I check to make sure that that database was created. So when you make a database and you call the constructor for it, it's going to not only make the database if it doesn't exist, it's going to open the database. So it does both. If the database doesn't exist, it's going to go through and create the database and then open it. Or if it already the file exists on disk, it's going to just go through, grab that database, open it up. So then I just need to get a pointer to it to basically make sure that it's not null, right? So that's what this code does here. We're unwrapping it. And then I'm going to go through and create a collection. Now, here's the nice thing about collections. They work the same way as databases in the sense that when I call the create collection, if the collection doesn't exist, it's going to create it and return it. But if the collection already exists, it will just return the existing collection, which is kind of nice. And then since that's nullable, this call, I need to go through and then unwrap it, right? So go through and say, hey, look, I need to make sure it's not null or nil. And if it's not nil, then I'm going to go through and continue on with my setup of the database. We are doing queries, and so because of that, I'm going to create an index. Now, indexes can make queries faster, but remember, they can make writes slower. So when you need to make speed, right, you should add an index, but don't go crazy about it. I know there's a lot of people that will confuse you about this. My theory is that, create the indexes that you need for performance reasons based on what you're querying, but don't add random indexes in or indexes that you don't think that you may never use. Be very specific about it, because otherwise you can literally slow down writes. On iOS and modern devices, to tell you the truth though, they're so fast. They're like the speed of a laptop that usually in a performance game, you could add an index in and it's gonna not be a huge deal. However, if you create 200 indexes, you're gonna have some problems, right? I've never seen a mobile app need that many indexes. Instead, probably, the average mobile app that I've written, can get away with somewhere between, 5 and 10 indexes, and you're probably down to all the queries that you need. So here I'm going to cache those queries. And I talked about that earlier, that, we're going to kind of get those queries right here into memory. And by doing that, they're going to be compiled down, and that's going to make it a little bit faster so I can reuse those queries. I have two of them. I have one for creating just getting all the tasks, regardless of who the person is logged in. Then I have the query that's going to go through and add a where clause to it that says only get the task for this particular user. This order by the document ID was from the original app. If you go look at the original query that Mongo was doing, they were also ordering it by the app ID. I probably would not do that. I'd probably order it by the username, but I just followed the conversion because this is conversion. I followed through their logic of how to filter these in the order bys. So we make those two. Then once we need to do that, we're going to set up the replicator. The replicator is what's going to handle replication, Now the replicator needs a config. So the first thing we need to do is get the components up and running to actually build a replicator config. The first thing we need to know is where is in your app service. So for that, we need to pull that endpoint from the configuration. That's going to be the app endpoint out there that App Services and Capella is using, right? So I'm going to get that out. I'm going to throw it into a URL. Once I throw it into a URL, I can validate that I have it, and then I can make a URL endpoint by passing a URL in, and this is a Couchbase Lite object that we can then use for the replicator config. You'll see here that in the very next line, I make a replicator config. It requires a URL endpoint, right? It needs to know where to go on the internet to get and sync information. Now, the next part of this is a replicator type. And replicator types are several. There's push, pull, and push and pull. I want push and pull, which means anytime the App Services has a new document, I would like that, so I'm going to pull that document. But also, anytime I add documents to my local database, I want to push those out to App Services. Now, you're going to say, well, why would you ever have push? Well, I'll give you an example. It's like an IoT device. Maybe an IoT device that's a sensor that has just temperature monitoring. Well, on these IoT devices, a lot of times, all you're ever doing is really taking that sensor data and then pushing it out somewhere. And you may actually go through it and normalize that data down, or even like summarize that data and then push it out. But usually that sensor information is a push only. And so that's the pattern for that. Now, you may also be writing a dashboard application. Maybe it's an iPad application for leadership that gives you various insights into data. Well, usually these dashboard applications, you don't write to the database. Well, then that's maybe a pull, where you just pull the documents down from Couchbase Capella app services without modifying them. And so by doing that, you can kind of make a decision how you want your replicator to run. Do you want to get information and also send information, or do you just want to receive or send? Continuous means that the replicator is going to continue to run until you tell it to stop. Okay. You could do a one-time replicator, or you can do it continuously. In this app, we're going to continue to run no matter what. One nice thing about this is that if you lose internet connectivity, that's fine. It will go into offline mode, and when you have continuous set to true, the second that you have internet and it's available, it'll just automatically start syncing again. And we saw that in the previous video. If you watch me demo and I turned the app offline, you notice I didn't do really anything magic. I just added some data, but the minute I turned it back online, it automatically synced. It did that because continuous is set to true. Now, in order to sync information to app services, you have to, in your app services endpoint, have it configured with what collections you want to sync information. You also need something called the data access and data validation script, which goes through and does the security behind this. Documents are stored in Couchbase Capella collections. However, we take the security as something called a channel. The collection configuration allows us to then tell the replicator, hey, which collections from this app endpoint do I want to sync? And so you can have one or many collections. Right now, we only have one collection in this application. It's called the task collection. So we're going to add that pointer to that, and we got that way up here. If you look here, we got we took the task collection. We call it collection because we wanted to get that possible nillable out of there, make sure it's not nil. And we send in a blank collection. Now, collection configuration, you can have all kinds of other things inside of it. You could filter out documents by document ID, saying, you know what, I only want to sync these particular document IDs. Or you can filter out by channel name if you want. In this particular application, it's a pretty basic one, so I'm just going to keep a blank collection configuration and then pass in my task collection and say, I would like to add that to my replicator config. Please sync all the documents in that collection, right? And so that's going to be that task collection in Capella based on the data validation script that I have that you did in the previous video and set up. The next part is we need to give it a username and password to log into it, right? Now, I told you earlier, you can use OpenID Connect, and if you did that, it would be a different configuration here. But because we're using just a basic username and password, we're going to set up a basic authenticator. This is a Couchbase Lite SDK, and you just send in a username, password. You send then the config to the authenticator to this object that we create. And this is anytime it tries to sync, it's going to use that username and password to set it up. Finally, once we have the config done, we can make a new replicator. And we do that by calling the constructor of a replicator and passing in the configuration. Now, before we start the replicator, we can go through and we can check the status of what's going on with the replicator. And we can do that via a change listener. Okay? A change listener is just basically an event-driven based API. And we're going to do is say, we're going to add the status. So this add change listener is going to go through and check the status of the replicator. And what we're looking for is errors specifically. And so anytime there's an error, we're going to go through and print out to just the log where it'll make it easy that, hey, look, something went wrong. By doing that, if you're debugging the application, you can kind of say, go through and try to figure out what's going on with the application to try to figure out like maybe you have the configuration set wrong or something like that. Finally, the replicator itself, I'm going to, if the replicator got created, because this is a nillable event, right? Maybe something went wrong with your config, so it couldn't create one. I'm gonna basically unbox that or basically typecast that out to not be a nillable, and then I'm gonna call the replicator start. Once I call the replicator start, I know the database and everything's set up, and then I can go through and I can tell the app that the state is to the database being open. All right, and that's it. That's how we initialize the database. Now that's a lot, pack of lunch moment, but that would get the database initialized up. Once that happens, then the open database view, okay, right here has to check the state to see whether or not it's going to show the progress view when it's connected to the database, or if the database is open, then show the items view. And of course, we're going to pass in a couple different things about the state of what's going on, whether or not the application is offline or not, for example. And then show my items as that switch, right? So if the switch, if we take a look at it, that switch is right here. So right here, show my only task. We're going to set the state of that and then say, hey, look, we're going to pass in whether or not that state's there, because that's going to change the item view, whether or not it should show my task or all tasks. And you can see here on that items view, anytime we change the switch, we're going to change the view model's items to be from the set my items to set all items. Okay. The last thing we need to do is by default, we're going to set it to just my items. So if no one's ever done the switch, we're going to set it by default to that. Here is the code for changing the offline and online mode. So if we take a look at that here, that's when you click this little Wi-Fi. I changed that code out to call the view models pause sync or resume sync. Now, if we go look at the open database view model, we'll see that all those do is call the database service. So this takes in the database service. It's either going to cause the pause or resume based on that. And that's it for getting the application to keep its state of understanding what view it should show. Okay. So with that, let's take a look. And of course, because this initialize, this open view is kind of handling the state of the application, the shell of the application drawing. It also handles the menu up here for logout and for adding a new item. So we need to also handle what happens when somebody does add one, and that's this add task. So you can see here, we go through, we get the current user, we go through and then get the task from this, right? It sends in the text of the actual summary item. So I'm going to go back here and show you when we click on this, all it asks you for is a piece of text. And so we get that back from this screen. And then we go through, make sure the user's logged in. If it is, we go make a new item. We set the task is completed to false because by default, all tasks are not completed. And then what we do is we use JSON serialization. So inside of the task itself, I go through and call a toJSON method and get that JSON string. And then I make something called a mutable document. In Couchbase, all documents are all information in the database, we save them as documents. When you want to update a document, you make a mutable document. When you read a database from the database, it's just a regular document. It's immutable, but you can convert a regular document to a mutable document so you can make changes. So the mutable document API does allow you to just send a JSON string and then an ID, a document ID for that, very similar to the _ID that MongoDB Realm has for its SDK. And so I make that mutable document and then I tell the collection to just save it, okay? And that database service then will go through and do that. Now, to start to talk about this, what changes do I need to make in the application to get this item to work? Well, quite a few to tell you the truth. If we go look at Mongo's code real quick here, this is probably one of the biggest things that you'll have to also understand is that, you're gonna have to change out your model, right? And so in here we have an item. An item you'll see here, it inherits from an object and an object key identifiable. And you can see here we have a bunch of macros in front of it that are going through and doing certain things based on this persisted state. And this is part of the Mongo SDK, okay? You can see here it's importing Realm Swift. We don't do that the same way. We are very vanilla from that standpoint. So because of that, if we go back and look at Xcode, what we're gonna find is that I just make this a codable. So you can see here, a codable and identifiable. Codable so that we can serialize it. We have the 4 properties that you saw earlier in the Mongo code, right? And I have a constructor that you can pass in that's gonna automatically make the ID for the document based on a UUID. And I set the fields. Now, I needed a convenience initialization from the JSON string. So if you send me a JSON string, can I just serialize one of these items up? Because a lot of times from the database, you're going to get an item and you're going to get a result set of items or like a query change set of items. It's going to just be think of it like an array in memory of all these different items that you then have to somehow convert from that format into one of these tasks, these items that we have, right? So we're a JSON database, a document database, right? So it's really easy to use JSON strings for this. You don't have to. You could make a map. You can get the results back as a dictionary, for example. And then you could write some mapping code that looks at each field in the dictionary that makes a decision on that field, right? And then goes through and says, oh, okay, based on this, I'm going to set this value and this object to that from the dictionary. That's a lot of mapping code, and serialization is pretty easy to do. Now, remember, because it's serialization, one of the problems is going to be is that JSON is schemaless. And the is completed field doesn't have to be in the document. In fact, it's possible that it's not in the document at all. Well, that means that we need a custom decoder to decode the JSON just in case that field's not available. So you can see here, I have to, the is completed field specifically, if you're using like the Android version of the application, it doesnent give you the is completed field by default when you make a new item. And so because I had to take that into account, right? This application may have a SwiftUI version that's written in SwiftUI, but it may also have an Android version. And I have to follow the business logic of all those to guarantee that the data is always going to work. And since this was a conversion, I took that to heart to mean that, look, this data's got to be compatible with all the different versions of this application running, regardless of the language it's written in. So this init right here is a decoder, a custom decoder that's going to go through and decode each one of the fields based on whether or not they could be possibly present in the document itself. If it's not document, we're going to default it as completed to false. And of course, finally, we have an encoder. This is just going to take the information and code it to a JSON string. And then we have our coding keys. This is part of implementing the codables protocol that we do here. Okay. And finally, we have this helper function to JSON. That's just going to take it and encode the document itself to JSON string so that we then can save it to the database. And that's what this is using here. When I say task to JSON, we're then using that encoding to go through, encode it, and save it to the database. So that's basically the main screen of the application, showing you how I converted it. Was, anytime you hit this plus, it's going to go into that view model. That view model is then going to call the database service. It's going to go through and add that to the database. And so that's adding one, right? So how do we get the, I guess the other thing is you can slide and do delete. So let's talk about that real quick, right? So if we go back to our open database view model, oops, sorry, not the open database view model, it would be the items view model, right? If we go to the items, we can see here that in here we have the ability to delete, because that's the items is the listing of the tasks, right? So that means that items view model would be the thing that's holding the swipe event and then saying what should happen when we delete it. So we send an item to be deleted, we call the database service, and it deletes one. So if we go look at the database service, this is pretty basic. If we were to pull down the list here to go look for delete, you'll see that we go through, make sure we can get the collection. Obviously, if we can't get the collection, that's bad. We set an error so that we can show it on the screen saying something went wrong here. We go get the document from the database, because you can't delete a document without, having it in the database. So we need to validate that it's actually in the database. So we go to the database, so the collection, we get that document, and then we go through and find the owner ID. And this is a business rule that was in the original application that Realm had, is that you can't delete documents you don't own. So we validate that you are the owner of the application. And if you're not, we're going to give you an error message that says, sorry, you don't own this application. But if you do own the document, then we're going to delete it by calling the collection delete API and passing in the document that we pulled from the collection. So we took the item from in memory, went to the database, got a document for it, right? This is an immutable document because, like I told you earlier, the document API, when you get a document from the database, it's immutable. But we can pass that immutable document into the delete API here then to delete it. And that's how we're getting our delete function. So we look here, we've went through and we did the add. Now we've done delete. Now you can modify an item, it turns out, and that's when you click on it. So let's go through and take a look at that. So if you were to select this, you can go through and modify it, right? So that we also need to take a look and take care of, right? So if we take a look here, we do have an update for that item here. And I'm gonna go show that view model. So there is a view model for this. If we go back to items detail, this is where we updated item. So in the UI, the detail view is what actually it goes through and allows you to update an item. So when you click on an item here, this is the item detail view. Okay, so you can see here, it's in this component here. So I made a view model for that. You can see here that basically all that happens and what I updated to say, hey, look, I'm gonna make a new function that calls the database. I'm gonna give you the item. I'm gonna give you the is completed. This is the new state, right? Of that, we're gonna say, okay, is the switch on or off? And then the new text for the item itself. So you're getting the original and then the changes to it. That calls the database service. So let's go take a look at the database service real quick here. In the database service, I can then go through and take a look at the update function. You can see here, it's almost the same as delete, very similar. Well, first thing we're gonna do is we're gonna go get our collection. If the collection doesn't exist or something went bad, we can give back saying, hey, look, something went wrong with that. We need to go get the document because we're doing an update. So the first thing we do is we go get the document from the database. If we can't get the document back, that's a problem because we're trying to do an update, right? It's not an insert. We go through and check the owner ID to make sure that you are the owner of it. If you, I talked about this earlier, in the original version of the Realm app, if you weren't the owner, you can't make changes to it. Now, finally, I talked about this a little bit earlier. Documents are immutable. So I got a document from the database here, but it's not mutable. You can't make changes to it. So I'm gonna call the toMutable function to make it so that I can make changes to it. Now, there's two ways you can talk to documents. You can serialize information, right? And that's one perfectly way to do it, but I wanted to show you the alternative. Another alternative to basically writing changes to a document is instead of JSON serialization, you can just call the key value API that will allow you to set the value based on a key. And so in the document, we know that we have this is completed field. And so we can just set the new value to it. So this is the key is complete. And we can just set it based on the value that's passed in. This is the value from the switch. The same thing goes for the summary string, right? So we're gonna say for the key of summary, we're gonna go through and take whatever the task is, and we're going to go through and get the, and set that value for this document. So we're changing the switched value possibly, and also then the text that came with it. And then since this is now a mutable document, we can just call the collection save again, and it's going to go through and do that mutation, that change to it. So two different ways you can communicate with documents. You could do mapping, right? Or you could do JSON serialization. They're both legitimate ways of doing it. Obviously, JSON serialization can come at a cost of one, having to do your codables code, right? And understand your fields that are available versus not available, right? So that's a thing that you may require more code here. And obviously serialization comes at a cost of CPU juice, right? Because if you're doing mapping code here, this is efficient, very efficient way of setting this, where in codability, you have to bring all that stuff in, the serializer into memory. It's a bigger hit in performance. However, if you have 100 fields in your document, writing 100 fields of mapping versus this codable API, codables tend to be a little bit more efficient from a code length standpoint, right? You have to decide how you want to do it. Both of them are valid. I use a mixture of both in most of my applications. Whatever makes sense at the time based on the efficiencies of it, that's what I end up using. And so I'll leave that up to you to decide, but you now have an example of using the add API as you look in this code example, use the JSON serialization, and then when we update a document, we actually use the key value, setting the value based on that API in Couchbase Lite. So we went through and we talked about delete, add, and update. So those are the three parts of CRUD. If we were to say CRUD is create, read, update, and delete. The last thing we're going to say for last, which we need to go over and talk about then, is how do we get the items from the database, right? And show them in that list. Well, that's all done in the items view model, the items view, and then the database service. So we're going to talk about the items view model next, right here. So here we have our items view model. We can see here that we have two different things that happen. We have a set all items, and that's what happens when that switch changes. We say, I want to get all the items, or we can set it for my items only. And then based on this, it's calling the same function, set task list change observable. We send in the subscription type, and the subscription type is from the original Realm application. That's an enum that Realm used to keep track of the subscription for the flexible query, okay? And there's nothing wrong with that, right? You can reuse that enum if you want to. And so I decided there's no need to change that code out because this is a good version. I'll just reuse their enum and I'll use that to set what query I should run inside of Couchbase Lite. Now, this is going to use a callback. And we'll take a look at this in a second in the database. So I'm going to say, hey, look, I'm going to set a callback, say what happens when any documents change in this query. And I'm just going to say, call this update items. And this update items is just going to remove and then append the items to the list of items that are observable that we already have here. And this is an array. You can see that's a published array of items. And so all we're going to do is remove the previous items and then add the new items to append it to that list. And that should update the UI. So let's take a look at all items versus my items to see how that works in the database then. So when we call this. So if we take a look at database service, we're going to go back up to database service here, take a look at this particular code here. You'll see here that we're going to take in that subscription type. We're going to take in an observer, which is this is just a callback. And we're going to send back, this is going to be some async code. So we're going to send back, we don't know when, but we're going to send back an array of items that is possible nullable. We need to go through and keep track of our current observer so that we can use it later. So we're going to do that first. We're going to go through and make sure that we set a pointer to that. We're then going to go through and define our query and then set the query based on whatever subscription type comes in. And you'll see here, the first thing I do is make sure that we don't already have an observable running. If we already have an observable running and nothing's changed in the switch, then we don't need to do anything, okay? But if that isn't the case, then we need to go through and remove our listener token. So our listener token is a pointer to the actual current running query that is something called a live query in Couchbase Lite. Now live queries are pretty neat. They're an event-based system that shows you any queries on the fly. And if we go back to our documentation here, I go through and explain this. And so if we go through here to database service, I talk about cache queries. Eventually, I'll come through and talk about each one of the functions, great details. And when I come to here, I'm going to have a link to the live query API. This is a great way to understand how this works, but it's pretty basic. You have a change listener. Anytime any of the documents in a query change, it will run that code. It's that simple. So what we're going to go through and talk about then, how do I set that up? Well, one, I need to figure out which query to run. If it's constants all items, well, then I'm going to run the query for all tasks. If it's a query for just yours, I'm going to just run that query then, right? So the first thing I do is I take that query defined up here and I make a decision which version of those queries I need to run. The next thing I need to do is I need to get this to be not nullable. So I'm going to get this to be a run query. And then I'm going to, on the query itself, I'm going to run a change listener. Change listener is going to take in this one right here, and we're going to add in the add change listener. This is the live query API, right? I'm going to make an array because I don't know, these are going to store the items and return back. And I'm going to go through the change result, looking at the results of those. And I'm going to loop through each one of the items that came back from this query change, right? So something changed in the query, one of the documents has changed. I'm going to loop back through all those, and I'm going to get an individual result of that array that came back. Now, there could be none. There could be no documents that come back, so that's why I need this let statement to just go through and kind of check to make sure that this is not nil. Once I get an item back, as I loop through it, I'm going to then convert it to JSON, and then from there, I'm going to deserialize it, so I can get back the data access version of this object. And this is just to unwrap the item. Once I do that, I can unwrap the data access object over to an actual item and then send it into the array itself that we have set right here. And then when I'm done, I can then basically go through and say, I'm going to use concurrency to send in the results back to the observable that was sent to me, the callback basically, right? And that is the API syntax for this. Now you're probably saying, what, the data access object, that's something new I added into the application to dewrap the query. Okay, so you can see here, I have a data access object that's also codable. It all has is an item. And then the item gets set to that item, and then I have the ability to get it, to deserialize this by calling this convenience here for the constructor. And this will go through it and get it back. Now the reason for that, and I do want to call this out because most people don't know this about the Couchbase Lite SDK. I'm going to go back to the database init so we can take a look at the actual query. So let's go back to the initialize database function here and take a look at this real quick so I can call this out. See this as item right here? Every item that comes back from a query result change is going to be named an item, okay? And so it's a separate, think of it like an entity, right? That's going to come back from this. So this as statement is going to tell it what that name is. If you don't give it a name, it's going to use the collection name, okay? And this is the data access object then, right? So my DAO, my data access object, is going to be this name. And so that's why you'll see here, it has one item in it. If I were to call that something else, say for example, I were to call this tasks, or if I were to call this, business object, whatever I call it here, I have to make my data access object the same name. Because if I don't make it the same name, I can't deserialize it down. Okay, this is the name of the thing that came back from the query. So I just happen to call it item here. If I were to make this, like, for example, business object, BO, well then inside of here, my data object here, I need to make this BO. And if I didn't, then this wouldn't match. The serialization wouldn't match. So just, I want to make sure you understand why the data access object exists, so that you can understand why that code was added to the item. And that's pretty much it. That's how the live query goes through and runs. And so let's go back here. And so you can see here then it calls the callback that was passed in earlier. You can see here we have this observer callback. We kind of get it back here, unbox it so we can use it. And then we just call that via the concurrency API. And that means now the items view model can then run the update because that's what we pass in, right? We pass this in, this function. That's what's going to remove all the items from the array and then append them back. That's a default implementation of live query out of the box for Couchbase Lite. So with that, that's kind of the major things I did for the conversion. So in summary, what I want to kind of say is that one, there's no SwiftUI SDK specifically for Couchbase Lite. There's a Swift SDK, but not something that's going to automatically bind your items into your views. And so because of that, I went with the 3-tier model. I went with a database service, I went with view models, and then I went with views. And my old goal was to do separation of my code. All my database code will be in one service that's going to run with concurrency. So I'm going to use the actor, right, to do that. My view models are going to be on the main actor because they're going to talk to the main UI, right? And so I want to make sure that they're on the UI thread. They're going to be observables so that I can publish the results, and that's going to cause the bindings to kick in. So anytime the item changes, the UI should dynamically update. And then of course I have my views, and each one of my views is then going to take the information from the view model and publish it out. So in my items here, you can see here I have my bindings to my view. If we go look here and see from my items view, I'm going to send the items list right here. I'm going to draw the items list. The items list is then going to go through and use the items view model to go through and get my array here of items, right? So if I go look at the items view, where's the items list? Items list right here. This is going to then basically have the items view model right here. It's going to then go through the view model of items, and it's going to make a row for each one of the items in this array by doing the for each. And of course, this is the onDelete that I showed you earlier. If you were to swipe over it, it's going to perform that delete items, which is just going to call the view model based on the item that was selected from the array, and then it's going to call the view model delete function. So we can see here, this is, obviously some code was modified for this because of the fact that we have view models now instead of just binding directly instead of the realm code. This is the conversion that I did for Swift. It is certainly more code than some of the other platforms because the SwiftUI SDK for Realm very specifically gives you pretty deep integration into the actual UI. Also makes your UI kind of very hard to test, right? So that's the disadvantage of having that deep level of integration is that, how do you write mocks for all that? In this world with this code, this is completely testable. Your view model could have a mock version of that view model. You can implement this with protocols. You can write then test against those view models and validate that worked. You can write a protocol for your database service. You can then go through and make a mock version of that database service, and you can turn this whole entire application into a bunch of unit tests or any kind of integration tests, whatever you want, right? Whatever testing framework you want to use, you make your app more testable, and that makes it a little bit more stable, in my opinion. So I want to appreciate your time for going through and doing the code review with me on this particular application. And I look forward to seeing you in the future.